Okay, hello everyone. So our next topic is drift velocity. So first we'll understand what is the meaning of drift velocity and then the parameters on which drift velocity will depend. And then how questions will be asked in your exam. And there are two very important derivations in this lecture. So please keep your notebook handy with you so that you can write the derivations and then I'll send an online quiz that you have to submit. Okay, so moving to our first slide. So what do we mean by drift velocity? So if you'll know that when you connect a battery, then there is one positive terminal and there is one negative terminal. So this is negative terminal and this one is positive terminal. So what will happen is as soon as we'll switch on, the electrons will drift from negative side to the positive side. And how electron will move, you can see this red colored dot in this figure. So there's a red colored dot, this one. So just see the movement of this electron, how this electron will move from negative to the positive terminal of the battery. So the electron will get attracted to the positive terminal. So it will collide with this atom and with this atom and with this atom and with this atom. So there will be successive number of collisions, when electron will drift from negative to the positive side. So we'll calculate average velocity with which an electron will drift from negative to positive terminal of battery. Now remember, there will be a term that will come, that is relaxation time. So relaxation time is basically the time between two collisions. Suppose electron collided with this atom at type T1 and this atom at time T2. So relaxation time will be T2 minus T1 because in between these two times the electron is relaxing. Okay, so now how will we derive the formula for drift velocity? So we have already read about this formula, that potential difference is equal to electric field into length. So basically as soon as we switch on the battery, there will be potential difference. If there is potential difference, then there will be electric field. If there is electric field, then there will be force on the charges. So force on charge is F equal to QE. This formula we have already covered in electrostatics. Since electron is moving, so force will be equal to mass of electron into acceleration equal to charge of electron is minus E and electric field is E. So acceleration of electron will be minus E into capital E, that is electric field, divided by mass of electron. So you have to remember this formula of acceleration of an electron. Now moving to first equation of motion. Since acceleration is constant, so we can use V equal to U plus AT. Suppose there are n number of electrons. See, there can be n number of electrons in a wire. So for ith electron, I'll write the equation like this: Vi equal to Ui plus A into Ti. Now what we'll do is we'll add velocity for all the electrons. So putting summation I equal to 1 to n, summation I equal to 1 to n, and summation I equal to 1 to n. Now remember, initial velocity is random. After colliding with an atom, an electron go in any random direction. So sum of initial velocity of all the electrons is zero, because if electrons are moving randomly, suppose electrons are moving just randomly, then current is zero. It means the total electrons going from left to right are equal to the total number of electrons coming from right to left. So random sum of random velocity will be equal to zero since current is zero. So summation of Ui can be taken to be zero. Now we have to find out average velocity. We have n electrons, so we will divide both the sides by n. Since summation of Ui is zero and average velocity of electrons is drift velocity, so Vi by n will be drift velocity. Putting value of acceleration, that is minus E into E by m, and summation of Ti by n is tau. Now what is tau? Tau is basically average time between two collisions. So what we have done is we have calculated a relaxation time for all the electrons, and then we have divided it by n. So tau is relaxation time, that is average time taken between two collisions. So this is how you have to derive drift velocity. So formula for drift velocity is minus E, that is charge of electron, into E, that is electric field, into tau, that is relaxation time, divided by me, that is mass of electron. Now again, why we have taken summation of Ui to be equal to 0? Because as soon as an electron will collide with an atom, it can go in any random direction, and sum of all the random velocities is to be taken to be 0. The reason for this is that when electrons are moving randomly, current is zero. Current is zero, it means that the total number of electrons moving from left to right will be equal to total number of electrons moving from right to left. So basically adding up all the velocities, since one electron is going from left to right, another is coming from right to left, so both the velocities will add up to zero. That is the reason why we have taken ui to be equal to zero. So you have to write down this derivation in your copy, that is derivation of drift velocity. Now factors on which drift velocity depends. Now Vd is basically equal to minus E, that is a constant, into electric field, that is not constant. Tau, it is also not constant, divided by mass of electron, it is constant. So basically we have two parameters, electric field and relaxation time. Now drift velocity is directly proportional to electric field. And if you know that potential difference V can be written to be equal to V equal to E into L. So basically potential difference is V equal to E into L. So E can be written as V by L. So if you will change V, then Vd will change. If you will change length, then Vd will change. So there are basically two important parameters, potential difference and length. Now there's another parameter, that is relaxation time tau. If you'll see, drift velocity is directly proportional to tau. Tau is relaxation time. And remember that relaxation time is inversely proportional to temperature. If you will increase the temperature, then atoms will oscillate. If atoms will oscillate, then collisions will happen frequently. It means tau will decrease. So if you will increase temperature, then tau will decrease and drift velocity will decrease. And if you will decrease temperature, then tau will increase and drift velocity will increase. So you have to remember this formula. So now the question will have some parameter and you have to find out how the parameters are changing. So to remember this formula and this concept, that drift velocity is directly proportional to relaxation time, which is inversely proportional to temperature. Okay, so next important derivation is relation between current and drift velocity. Now here is a wire of cross section area A and length L. So volume of this wire will be A into L, and suppose N is number of electrons per unit volume. So in unit volume we have N electrons, that is in 1 meter cube. We have N electrons, so in A into L total number of electrons will be NaL. Okay, so this is the total number of electrons. Now charge of one electron is E minus, so total charge will be NaLe minus, and current is charge flowing per unit time. So NaLe minus divided by T, and length divided by time will be velocity, that is drift velocity. So basically current is equal to NaEVD. Okay, now on the basis of this formulas, you have to submit an online quiz that is there in the description below, and also with the message that you have received for this video. So to submit that quiz, and if you have any doubt, you can send me on WhatsApp. Okay, have a great day. Thanks.